So let's go ahead and go to this. So let's say that we don't want to, most of the time you're not going to be providing context to these models via text files. That seems rather silly. You might be getting that context, let's say from websites or maybe internal documentation or something like that. Here I'm subbing in kind of websites generally for that. So let's say that we want to pull a website and then answer questions from that website. Well, I'm going to use this HTML to Markdown package. Thanks, Johannes, if you ever hear this. And what I'm going to do is pull the contribute field from the Go website. So if you look at this page, if you look at this page, then it has a bunch of info on it, right? Blah, 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 big page. So we're going to pull that. We're going to convert it to Markdown. So I have that Markdown string. I'm going to do a little bit of cleanup on this. And then I'm going to do an interesting thing that will allow us to better use this functionality. So in the previous example, I had a small amount of context. This isn't that much text, right? But if I have a full page of information like this, most of these models, including the sort of closed ones, the GPTs or whatever like that, are not going to do that well over large contexts of information. So they just simply don't work very well because they forget a bunch of stuff in the middle. So what we're going to do is we're actually going to take that larger context and we're going to split it out. And the way that I like to split it out is in a split size with an overlap. So basically rolling windows of this text that overlap by some degree. That way you're not arbitrarily cutting off some sentence and losing context. Just to give you a sense of what this will look like, I'm going to print one chunk out of here and then the number of chunks that I'm splitting this into. So here. Cool. And so this pulls that, and then you can see I get 59 chunks. This is kind of about the size of one of those chunks, and then they're overlapping. So that's thing one we want to do is split out our text into chunks. Next, what we're going to do is we're going to vectorize those chunks. What this means, I have a picture here that might aid this, is the following. We're going to take whatever documents that we want to operate on, split them into chunks, which is what we already did, and we're going to convert each of those chunks into what's called a vector representation or embedding. And this vector representation or embedding is going to allow us to do semantic search over these chunks. All those fancy words mean is that if I have a user query input and I convert that to this set of vectors, and then I have chunks in the same space, in the same vector space, I can just do a straight up comparison between this numerical representation of my user query and this numerical representation of my chunks to get the closest matching chunks. So it's a search problem, it's a retrieval problem. I then get the relevant chunks, I plug them into my prompt template and answer my question. And then hopefully I have success, right? So here, what I'm going to do is I'm going to do the same thing that I did before, which is grab the website, except this time I'm going to use a slightly different API, the one from Cohere. I like their embeddings quite a bit. They also have an open source version of these embeddings. And I'm going to, for every one of these chunks, I'm going to send batches of them to this embedding endpoint, get them embedded, and then I'm going to save that out to an output JSON. So basically, I'm just going to pre-compute all of these embeddings. So here, and this will take not that long. And if I look at that chunks, so now I have a chunk, right, of text, and I have the corresponding vector representation. Now, most of the time, this was already mentioned in the chat, Most of the time, what you're going to do is you're going to store these not in a local JSON file, you're going to store them in a vector database, which I've referenced here. And the one that I like to use is LanceDB. It's a really great vector database for this and easy to use. But there's any number of them. There's Weaviate and Pinecone, and there's open source ones and there's not open source ones. The same thing with any database. Pick your poison. Do you want open source? Do you not? Do you want managed? Do you not? Do you want client server? Do you want embedded? There's all of those flavors of vector databases. This webinar is not about that, but suffice it to say, you would normally store these in that sort of vector database. So now we have our chunks, we have them vectorized. So what we can do now is go back to our next example, where we will do an example search of these. So what I'm going to do here is use this cosine similarity function, which just implements a cosine similarity, which is a metric between two vectors, to compare the vector distances between these vectors. So when I have an input, I'm going to load my chunks into memory. And then when I have an input, like what is the review process, and I have that input, then I can embed this message and then perform my search over those chunks to get a first most relevant chunk from the data. And then we're just going to print that. Okay, and here you can see we match to a chunk talking about the review process. And you can see this is very, very quick. Most vector comparisons like this are very quick.